Hello children, how are you all? I hope everyone is fine. Nowadays some rain also come to the this season, and the April, May is supposed to be rain also in Nagaland. So we also have to be stay safe and sincerely attend the class. Today I am teaching class 9 maths. My name is KP Bakchi, I am from GRU school. So today we will be start with the first chapter of class 9, that is what? You know, guess it? Yes, it's a number system. Okay? So today we will start our first topic of class 9 mathematics, number system. What is the topic name? Number system. Okay. Now, you might have known many numbers. Suppose you ask you, tell me a number. You telling 2, someone telling 5, someone telling 6. In class 8 also you know the number line. You know minus numbers. You know some numbers we can write in the numerator by denominators. But all the numbers you know particularly. Now today I will teach you all the number system in one go. Okay. Please look at here sincerely, very easy to understand. After that everything in front of your tip of your fingers, this number is this number is this, easily you can find it out, clear? So look at here, I will make some flow chart, after that you will get most of the ideas. So I indicate this circle, consider as N. N stand for natural number. Natural number, okay. Then recommend this circle as, indicate as W. So W stand for whole number. Clear? The third one we stand as Z, or you can indicate by I also. So we call integers. Then we indicate here in this circle as Q. Q indicate rational number. Rational number. And overall we consider as R. R indicate real number. Okay. Now what are the numbers? Please look at here. If I make some dot indicate a number, some of the dot I make it, so many we can write 1, 2, 3, many we can write. So that what's the indicate? Natural numbers are all positive numbers, is infinity, towards infinity. These are all natural numbers are positive numbers, this towards infinity. Then if I put 0 here, the dot indicate a number, you consider 0. That means whole number comes under not only this, look at here, 0 also, whole thing. That means 0, 1, 2, 3, 4, all are whole number. So whole number starting from 0 towards 1 to all the positive numbers. Easily you can recognize. Clear? Now we come to integers. Integers, if I indicate a dot as -2, this one indicate -3, this one indicate -4. So many dots we can write, many minus numbers. And here not only Z indicate in the whole. In the whole means who are there in under the whole? These are all like minus, 0, plus, all are integers. We learn in class 8 also integers. So integers such a numbers, negative numbers, 0 and positive numbers. All the numbers are integers. Clear? So easily we can find it out. Now Q. Q is called rational number, and rational number basically we have to indicate, we can express under the form of P by Q. where q should not be 0. Denominator number should not be 0. You can, an average number of numbers you can write, but q should not be 0. So q, such a numbers, you can give an example, like I am writing here 3 by 4. You can write here minus 4 by 7. This is negative rational numbers. Here you write 1 by 2, 3 by 5. Someone write 0.333 dot dot dot. That indicates 0. What is this case? The numbers are repeating or recurring, repeating. We make it the number which digit is repeating comes under bar. Bar means indicating repeating digits. Clear? That also we can make it in the form of p by q. So that's why we call it is also a rational number. Some number I am writing 3.5 is a decimal number, but is terminating because no more dot dot dot. That means it's not repeating, terminate. So such terminate numbers also called rational numbers, because then you are telling, sir, what about this minus 2? Yes, it's a rational number because that denominator is nothing, you can make 1. So what's indicate? Denominator should not be 0, any number I can put. So these also a rational number, like 0. Denominator nothing, so we can consider 0 by 1. That's why 0 also called rational number. Like 1, 2, 3, all the numbers are rational. So rational number, not only fraction form, not only minus, 0, plus, every numbers are rational numbers. Clear? Now we come to the real number. What is the real number? Before real number, you have to learn one number, that's IR. What is the indication of IR? Irrational number, okay? Irrational numbers. What is irrational number? The number under the form of radical sign. This is called radical sign, root. This is called square root. If I write cube root of 4, that also radical sign. This is also a irrational number. They are irrational numbers. Some numbers like non-terminating, this is called terminating, and this non-terminating repeating. Some numbers like, say I am writing 2.01, 011, 0111 dot dot dot. That means numbers are not repeating, rather they are increasing. See these numbers 01, 0 is okay, but 11 double, again 3. So is non-terminating also, not finish also, and not repeat also, is increasing. So such numbers are called non-terminating, non-repeating, and such numbers are called irrational numbers. Like another numbers, you might have knowing class 9 some portions also, class 8 geometry mensuration, pi, pi, pi. Pi indicate irrational numbers. Pi, actually pi is a ratio between the circumference and the diameter. The pi is a ratio between circumference, and if you divide it, actual value is 22 by 7. And rather than 3.14 we get approximate value. But if I divide it, its numbers nothing to be end, is keep on divisions. So that's numbers comes number very big numbers. So such numbers are non-terminating, non-repeating. So that's why pi is also called irrational numbers. So now all the irrational, all the rational, all integers, all whole number, all natural numbers, all comes under real number. R indicate real number. See, R indicate real numbers. So in this chart, all the numbers in your fingertips. And I recommend you to make one chart like this at home. If you make chart in this way easily and keep it in your home, all the numbers should be in your fingertips. Okay? So please try to make it at home in easily to understand. Now I will come to one by one some other numbers. Like say I told you terminating, non-terminating. You already explained rational numbers. What is rational number? You already explained. Integer also explained. So if we make it a short in one line, say real numbers are all the numbers are real numbers, and q is a rational numbers in the form of p by q. You under the form of p by q. You can enumerate examples, all the examples you can give. Integers also you can give. Now I am explaining you about what I told you, terminating. This part is called terminating decimal, and this is non-terminating repeating decimal, and this is non-terminating, non-repeating. I'll explain that part, okay? Look at here, the one rational numbers I consider is, Q is considered as 3 by 5. And I have to express this in the form of terminating decimal. So if we divide in the rough with the 3 with the 5, we call 5. So we cannot divide, put 0 decimal. So 5 6 are 30. No more remainder. So that means that the division is complete division. That's called terminating decimal. So we call 0.6 is a terminating decimal. The division cannot do anymore. So remainder 0. So that case we call terminating decimal. Now the question is, which numbers will we have terminating decimal? Look at this, another question I am giving you. Another rational numbers I am giving an example, 1 by 3. Let's see it's terminating or not. I divide here. When possible, 0.0, so 3 3s are 9. Again, 1 comes out because of decimal 0, 3 3s are 9. 1 0, 3 3s are 9. So it dot. So see, division is not complete. Such numbers are called non-terminating. This is terminating. This is a non-terminating but repeating decimal. We call recurring decimal. Okay, we call recurring decimal. So now we can write this one as in the form of 0.3 bar. Bar indicate repeating digits. The digits 3 is repeating. That's why I indicate bar. Clear? So this is called non-terminating repeating decimals, and this is terminating decimal. These are all also form of P by Q. Now the question is, this is also rational number, this is also rational numbers. Can you make from here to here? When from here to here easily we can make. For example, I am giving you say 3.5 is a terminating decimal like this. I have to change in the form of P by Q. How to change in the form of P by Q? Look at here. So if I write 35 by 10, removing decimal, and it comes 10, and you cancel it, 5 7s are 5 2s are. How much you get? 7 by 2. 5 7s are 5 2, 7 by 2, correct? So 7 by 2 in the form of P by Q or not? Yes. So that means the terminating decimal you can change into form of P by Q. Now my question is, how we can change this to this? So such type of numbers I am writing here once. 2.37 bar. Suppose only this one is bar. 77777, we write 7 bar. Clear? How we can change in the form of P by Q? Look at here. Here we can multiply with that number, what do you call, 10, 100, some different process. But I'll make you a shortcut idea. Clear? First you write the number ignoring everything. The number, all the numbers you write without consider any decimal or bar, like 2, 3, 7. I consider all the numbers ignoring decimal and bar. Clear? Now I have to subtract the numbers which does not repeat. Okay? Here which one is repeat? 7 is repeat, but 2, 3 is not repeating. Is not it? So we have to subtract the numbers which is not repeating. Clear? Now dividing by, you have to write as many 9. What do you have to write? As many 9 the numbers which are repeating. How many digits are repeating? Only one digit is repeating. That's why only 1 9. Clear? So one digit is repeating only. So 1 9. Now how many digits are not repeating just after decimal? This digit is not repeating just after decimal. Look at this. So that means that much zeros. If 3 digits are not repeating that decimal, that many zeros you have to put. So what you have to subtract? Which is not repeating, that one subtract. And all the numbers 2, 3, 7 you write. Now you subtract it. How much? 4. Then it's 1. Then it's 2. Okay? Understand? 3, 7 by 7 subtract 3, 4, 1, 2, and it's 90. Now if it is possible to cancel, you have to cancel it. How much you can cancel? By 2. 2 1s are 0, 2 7, 14. Okay? 2 45. Can you cancel any more? No. So we can get it now, 107 by 45. Look at this. In the terms of P by Q form or not? So this is the shortcut idea to reach to P by Q form. Clear? So this is non-terminating repeating decimal comes under P by Q. Now I will be telling you what is the difference between what we call rational numbers and irrational numbers. Clear? So now another points also remaining here. By looking at the P by Q form, how you know is terminating or non-terminating? That's depend on the property of the denominator Q. The Q should be a factor of 2. I am telling you what is the property? If the number is P by Q is terminating, okay. P by Q a rational number, this number is terminating if, what I am writing? IFF. IFF if means if and only if, I am pressuring that only the word if. If and only if means IFF if, okay. So if it is terminating if the factors of the denominator have the factors of the denominator will be 2, 5 or both 2 and 5. Then only you will be knowing this is of terminating decimal. You see, look at here, 5 is terminating. Last time one example I give you 3. 3 is not comes under C. 2, 5 or 2 or 5. That means it is not terminating. So that is the crucial point, clue of the denominator. Denominator which one here? Q. Q should be have factor of 2, either 5 or both, not other numbers. For example, if I write here 3 by 15. Now this type of question is also very tricky, either terminating or not. Sometimes if you go on the basis of this, you will be confused because 15 have LCM is 3, 5. So what is the factor? 3 and 5. So by look at the 3 and 5 and look at the definition, oh, it is not terminating. But it is not the lowest term. You have to think for the lowest term. If I cancel it, it will become 1 by 5. Now if it is 1 by 5, it is terminating because denominator only 5 factors. So that type of tricky question must be there in your question. So please rectify this. Please make sure the P by Q under the form of lowest term or not. Then only you check the terminating cases. Clear? Understand or not? One numbers I will tell you 7 by 15 is terminating or non-terminating. That time it is the lowest term. So we can go for the factor is 3 and 5 and 3 is not there in our list, so it is not terminating. Clear? So this case is understood, the terminating, non-terminating. Now I will explaining you the difference between what you call rational number and irrational numbers. The rational numbers and irrational numbers. What is the difference? Can you tell me? Anyone? The one difference is there, rational number can be expressed. These are rational numbers, no? Rational number can be expressed in the form of P by Q, where Q should not be 0. But irrational number is the difference I am telling. Irrational number are here irrational numbers. Irrational number, it cannot be expressed in the form of P by Q. There is the main difference between rational and irrational. Rational number can be expressed in the form of P by Q. Irrational numbers cannot be expressed in the form of P by Q. That is the difference between irrational and irrational. Now if I ask you what is the similarity between similarity between rational and irrational, how it is possible? Very important part is there. That similarity is, I am telling you, between rational and irrational. Rational and it's irrational, okay? Might have you guessed it? No. This is you know in class 8. Rational number can be expressed in a number line. For example, you might have 3 by 5. What is in the number line? Look at here. Suppose you make it here 0 and denominator 5 you can divide into 5 equal parts. See, the 5 equal parts. We write here 1. Why? It is 0 by 5 is 0. 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. When you say 5 by 5, you cancel, it become 1, no? It's a 5 by 5. Then it is 6 by 5, 7 by 5, 8 by 5, 9 by 5, 10 by 5 means 2. So that means between 0 to 1, each part we divide into 5 equal parts, depend on denominator. If its denominator is 4, we have to divide 4 equal parts, isn't it? So now easily we can find 1 by 5, 2 by 5, 3 by 5. So you can express here 3 by 5. So that way you can express rational number in the number line. And irrational number also you can express in the number line. How it will be? Say irrational numbers is root 2. I have to express in the number line. How it will be? I need a space, so I will do it here, okay? Look at this. How we can express root 2 in a number line? Say our question is root 2, you have to express in the number line. So draw a line. We need to know the help of another great laws, that is Pythagoras Theorem. I'll just briefly, I tell you briefly. It is a right triangle, is a 90 degree, is a hypotenuse, is perpendicular you consider, is a base you consider. If you look from here, is perpendicular base. Both are vice versa. So now the Pythagoras theorem says, is a Pythagoras short form theorem. What is this? Square of the hypotenuse, not the hypotenuse square, is equal to sum of the square of other two sides. What are other two? Is perpendicular and base. This is a Pythagoras theorem. We need to recreate this. Now look at here, how you express this. You draw a line, mark any point on the line as considered as O, mark at O, and take with the compass 1 centimeter arc, say 1 centimeter arc with the compass we took, is A. Consider as the point is A. And at the point of A, you draw one perpendicular. With the help of compass you can do, or we can do with the scale. Compass is better. Then compass we draw an arc. You know how to draw 90 degree? You have to draw an arc from here, 2 arcs, and join and produce. That way we can make 90 degree. Okay? So now look at here, from here you cut 1 centimeter after that. Say this point is B, is also 1 centimeter, this is also 1 centimeter. Clear? Then you join it. OB. What is the value of OB? OB is, this is 90 degree, no? So look at this, is the hypotenuse or not? Look at this hypotenuse. What is say? Hypotenuse square means OB square is equal to perpendicular is AB square plus OA square. So what is AB? 1 square plus 1 square. It's 1 plus 1 is 2. So OB square is 2. What is OB? Is square root of 2. You might have known, why square root of only, I'll tell you after this figure, the square root have 2 values, but we consider here only 1 value because it's a distance never negative, that's why we consider positive. I'll tell you the square root, all the square root have 2 values, clear? I'll tell you. So now root 2, this value is root 2. Then what we'll do? You keep your compass here and the pointer, take this radius like this and draw an arc. When you draw an arc, it's come to the line, intersect in the line. Since point is E and this point from there, okay, root 2 value is how much? 1 point something. So this distance consider as root 2. So we consider here as root 2. So we can find in the root 2 value in the number line. If you go with the scale, it will come like 1.4 approximately, 414. So this the value also we can, the irrational value also we can express in the number line. That is the similarity between irrational number and rational number. So what is that similarity? Rational number can be expressed in a number line, irrational number also can express in the number line. Understood? So this is the difference between similarity, difference and similarity between rational and irrational. Clear? Now I find, suppose you find like 1 and 2. This is also a rational number. I told you, no, P by Q form, 1 by 1, 2 by 1 we can write. But how many numbers we can find between two rational numbers, that is you have to check. Clear? Now look at here, I write 3 and 4. Find, say maybe 6 rational number between 3 and 4. How can we find between 3 and 4? This is this number, no? That's why we need to find some numbers. We have to know the visualize of a number. Then easily you can find. I'll show you one visualized number. Suppose the number I have to visualize, so 3.46. I have to visualize the number in the number line. Is a subdivision of a subdivision. How to visualize? You might have used magnifying glass in your at home sometimes. Magnifying glass, things are too small. This dot is too small, I can see. But if you use magnifying glass, then you can find this number is very big. How much closer you can. So that's why this small number now become like this by using magnifying glass. That means you have to come closer to the number. Then only the number will be very big. Is it not? So now I'll show you how we can visualize this. Look at here. This is 3 I consider the first number. After decimal not consider, after 3 the next whole number is 4. So I have to divide into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll make it the 4 here. Clear? Look at this. How we can visualize the number. So what is this number? 3.1, 3.2. 0.1 is increase. 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. And after that, how it become 4? 3.9 plus 0.1. How much? Is become 4.0, means 4. That way, we can reach to the number. Clear? So likewise, the next number is 0.4. 3.4 is here, no? And what is that? 3.5 here. So take these two numbers again in this number line. See, the number 3.4 here come closer with the magnifying glass. So it become 3.4. See, my letter also increase. And it is 3.5. See, I'm writing big letter compared to this. That means I'm closer to the number. Clear? So now again 10 division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is how much it will be? 3.41, 3.42, 3.43, 3.44, 3.45, 3.46, 3.47, 3.48 and 3.49. And after that 3.49 you have to add 0.01 because 0.1 increasing. See 4.1, 4.2, 0.1. It is 0, it is 1. Clear? So it is 0.5. See, you get 3.5 here. Isn't it? So what is 3.46? Here. So you can find in the number line 3.46. Likewise, between 3 and 4 many numbers are there. You can choose any 6 numbers out of the decimal because decimal is a rational number. We already explained P by Q form, is not it? So we can write, the answer is what? We can write 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, any 6 numbers you can write between 3 and 4. So that's why this is the way you can find rational number between many rational numbers. How many you can find? I am writing 6. How many you can find? Infinite number of. So between two rational number, there are infinite number of rational numbers. Okay? Even though if you want to find the irrational numbers, also we can show you. Okay? Look at here. So find, say, 2 irrational numbers. Example. Numbers between, and write in the short form, root 2 and root 3. What is the value of root 2? If you find in the number line, you will get, say, 2.141. Not terminating. And root 3? 2. What do you call root 3 value? Is 1.414. And what is root 3 value? Tell me. 1.732. Just we consider, many values are there. In between you have to find irrational. What is the irrational number? Non-terminating, non-repeating. In between. So what are the answers you can write? See, 1 after 1 is there, no? 2, 3, 4, 5, 6, 7, many are there. So you can write 1.20 in between 1 after the 0. Then again 200, 2000, non-terminating. You can even though write 1.5, 1, 5, 1, 1, 5, 1, 1, 1, 5, You can name many numbers. So they are asking 2, I am writing 2. So in this way, non-terminating, non-repeating decimal also comes also irrational numbers between two irrationals. Clear? So next class we will learn, what is the learn today? Please practice this one. Next class we will show you that the 4 fundamental operation between rational numbers and irrational numbers. What is the 4 fundamental operation? Please remember: addition, subtraction, multiplication and divisions. With that we can come to end today's class. Please refer and nicely, because we will learn nicely today how can you visualize a number, very big things, difference between and flow chart also. All the numbers now in your fingertips. Clear? Okay. So please sincerely do the assignment also when I give it to you. Now to today only practice this, and again I am showing this chart. You have to make it at home. It is really help you. Okay? This chart please make it at home and stay safe. Thank you. We'll meet you in the next class.